Right. So first, we want to finish our discussion on computer networks. Then we will move on to enterprise application development also. So we have done two MCQs. First, we'll finish the three structured papers. Okay, three structured papers because most of these questions are very straightforward as well. Okay, uh, right. So let's finish that and then move on to the last MCQ as well. Right. So we'll start with 2000. So we start with 2021 and come forward because anyway we are going to do all three. Okay. Right. So we'll start with 2021, paper two. Actually, I don't need to do much because most of the questions we have already done. Okay. Right. 2021, paper two. Question number one. Consider the network depicted in diagram. Actually, all 3 years, similar question is there as the first question. Uh, if you get the same similar question, it's very easy, but otherwise you need to think and answer. Consider the network depicted in the diagram above R1, R2, and R3 are routers. So we have three routers, R1, R1, R2, R3. Just read the question because you have enough time. A and B are two machines. So this is my A, this is my B. Partial information about the MAC and IP addresses of the interfaces of the machines and routers are given. Some information are given, but others are not given. Okay. Right. So this is A 192.168.11/28. MAC address is MAA because we need this information. B machine 192.168.3.1/28 again. MAC address is MBA. Right. So we have the router one details as well. Router one they have mentioned twice. Actually, you need only once. That's a typo. R1, that is this router. 192.168.2.1. 192.168.2.1 slash. Sorry, there are two things. Sorry for that. So you can see same router, two interfaces. Left side, right side. Sorry for that. We need both. That is A means this one. Routers this side. Okay. So be very careful. Actually, now only I saw it. So this is the left side because your router has two network cards. Right. So that is R1A. That is this side. 192.168.2.1. 192.168.2.1/30. And MAC address is MR1A. MR1A. And other side of the router is 192.168.25. Its MAC address is /30. MAC address is MR1B. MR1B, right? So those are the details. Right now we can start answering. They have not given this. The IP packet P sent from machine A has reached machine B. So IP packet sent from here has reached B. Okay, so that is what they have given. Uh, what is the suitable IP address for the network interface R2A? Justify your answer. Right? What is the suitable IP address for the network interface R2A? R2A is router 2. Router 2 also has two sides. A side. A side means this side, right? R2A. That is this, right? Because this is R2B. Okay, R2B. Right. So the question is, what is the suitable IP address for the network interface R2A? Justify your answer. Remember, this IP address and this IP address must be in the same subnet. Same subnet. So that means must have same subnet mask. Same subnet mask. Okay. So therefore, it must be the same range. So what is this address? 192.168.1.1 slash 28 means after 24 another 4. So therefore, we are only interested in last octal. Therefore, I'll write it in binary 0, 0, 0, 0, 0, 0, 0, 1 slash 28 means we have 4 more bits. This is the separation. So this is, it can be any of these IP address ranges because subnet mask is here, but this is already used. One is already used for this machine. Okay. Right. So the question is, what can be this one? So it can be, so the range is 192.168.1.0.0.0.0.0.0 to 1.1.1.1 because that is your subnet. So that means 192.168.1.0 right? 192.168.1.0 192.168.1. This is 1.248.16 minus 1.15. So these are the valid IP ranges, but 0 is reserved for the subnet ID. 15 is reserved for the broadcast ID. So therefore, anything between 1 and 14, but 1 is already used. Right, 1 is already used. So therefore, this IP address can be anything between 192.168.1.2 to 14. Anything. So we can say exactly what is the IP address, anything from that. What is a suitable IP address for this network? Justify your answer. You need to justify, right? Right. You can say anything from 2 to 14. 2 to 14 because 1 is already given, 0 is reserved, 15 is reserved. So if you know your subject, if you have understood subnetting and clarify all your doubts, so these are very easy questions. Right? And you need to explain that 0 is subnet ID, 15 is broadcast ID, 1 is already given. So therefore, anything between 2 and 14. I also need to explain that something like this. It is slash 24, therefore smallest is 0. This and all zeros, because this is not good enough. This is just a model answer, right? So it's examiner will check whether you have understood it. Right? Have you explained it? Otherwise, you will not get 10 marks. Maybe you will get only 5 marks, 6 marks if you just write the range. Right. Next question. What is the suitable IP address for the interface R3A? R3A. R3A is somewhere here. Now remember, this is one subnetwork. Now it's very important to understand this. So this is one subnetwork. Right? So this is another subnetwork. And this is another subnetwork. That is how you look at it. Because routers break it into subnetworks. Now this belongs to this subnetwork. Right? This subnetwork. And this subnetwork again, these two are the actually not three. We have 4 subnetworks, sorry. Because this is another subnetwork. Basically, this is another subnetwork. And this is another subnetwork. Actually, we have 4 subnetworks. Right? 4 subnetwork. Now, this one and this one is one subnetwork. And they ask what is the IP address for R3A, right? R3A. So remember, we know the IP address of the other interface, this part, and this are one subnetwork because routers separate subnetworks. Routers separate subnetwork. So we know IP address of one. So then other one must also be in that subnetwork, right? So therefore, you can, if you want to find the possible IP address or range for this one, you need to analyze this one. And this one says 192.168.2.30 is fourth one. Therefore, I'll make only this one as binary. That is 1, 2, 4. 4 plus 1 is 5. Then 4 zeros. Right? And 30 means we have after 24, 6 more. That means we have only 2 bits here. 2 bits here. Okay? 2 bits. So, okay, that is 0, 0, 0, 0, 0, 1 and 0, 1. 1, 2, 4. 4 plus 1 is 5. Remember, we can't touch this one because now the separation is 30th. So therefore, what is the range? That is 192.168.2.0, 0, 0, 0, 0, 0, 1, 0, 0 to 1, 1. Because we have only 2 bits to play around. Right? 2 bits to play around. And these 2 are reserved. So what is this? Okay, just give me 1 minute. Right, sorry for that. Right, let's continue. So what is the smallest ID? Anyway, that is all we can't use. That is 192.168.0. This is 0, 1, 2, 4. That is 0.4. 192.168.24. What is the biggest? 1, 1, 1, because this is anyway 1. And we have two ones. That is 1, 2, 4. 1, 2, 4, 8 minus 1, 7. But 4 and 7 we can't use because 4 is a subnet ID, 7 is the broadcast ID for this subnet. Of course, it has only 2 machines that we can't help. And again, you can see 5 is already assigned. 5 is already assigned to this. So therefore, it can't be 5 also. So therefore, now we have 4 and 7 can't be used. Then we have 5 and 6. But 5 is already assigned. So therefore, this one must be 6 because 4 we can't use, 7 we can't use, 5 is already used. The possibilities are 6 and 7 and possibilities are 5 and 6 because these are reserved. 5 and 6, 5 is already assigned to this, then this must be 6. Right? So this must be 6. So therefore, this IP address must be 192.168.26. 26. So you need to explain everything. Okay, you need to explain everything and say, therefore, the only available IP address for this one is 26. Okay, if it is not clear, I can explain it again. Right, C. Assume that all the ports in S2 are occupied. Switch 2. All the ports in switch 2 are occupied. Switch 2 is this one. Switch 2 is this one. Switch 2 are occupied. There are no free IP addresses available in the LAN connected through S2, and all machines with IP addresses are connected to S2. How many ports are there in the switch S2? That means how many machines are available can be assigned to the S2 or that subnetwork. So all are occupied means total number of machines, right? So that we are talking about this subnetwork now, this subnetwork. For this subnetwork, the available information is here, right? Available information is this IP address. So from that, we can identify the range because one IP address is there. So therefore, let's start with this 192. I'm referring to this one. 168.3. I'm interested in last octal only. Okay, last octal only. Dot one. One, I will put it into binary. 000000001. Okay, 000000001. And it is slash 28. So slash 28 means we have 4 bits here. We have 4 bits here. Okay. So that means we have 4 bits to work, play around. So that means we have the first address is 0000, last address is 1111. So that means how many machines? 2 to the power 4. How many IP addresses? 2 to the power 4. That is 16. But out of 16, 2 IP addresses are reserved. So therefore we have 14 because one is subnet ID, other one is broadcast ID. And also one address is assigned to this, that is 1. Okay. So therefore we have another one less anyway. So this is also connected to the switch. This is also connected to the switch. So therefore how many machines, practically how many machines we can connect? Anyway, this is also connected. Therefore that is fine. And one IP address is given to this router. Anyway, that is also connected to the switch. So therefore how many machines we can have? 2 to the power 4 minus 2 because these are IP addresses we can't use in machines or routers. So that means 16 minus 2 machines. That means 14 machines can be connected. Already a router and machine is connected. Router is also considered as a node. So therefore this switch must have maximum 14 slot because not 16 because these two IP addresses you can't use. So that means maximum number of slots or ports in this switch must be 40. Okay, 40. Yeah, 40. So you need to explain this. You need to explain this step by step. Okay. So this explanation is not good enough, right? Examiner is expecting much explanation from you guys. So that we deduce from this subnet mass or this CIDR value. Right. Next question. What was the destination MAC address on the link layer frame that carried packet P when it left R1? Justify your answer. Right. So the link layer means data frame. So what is the destination MAC address when the data packet, or actually this is data frame, we consider it as a packet, we consider it as a frame, but it when left R1, when it left R1 router. And remember data packet or data frames going from here to here, here to here. So therefore left R1 means you are leaving R1 router. So that means your next destination is R3. So remember that your data packet's IP address is source IP address is this one. Destination IP address is this one. So that IP address doesn't change. IP address doesn't change. Throughout this journey, source IP address is 192.168.1.1. Destination IP address is 192.168.3.1. But from here to here, source MAC address is this one, destination MAC address is this one. From here to here, source MAC address is this part, the right hand side of the router's MAC address. destination is left side of the router 1. From here to here, source MAC address is R1B, destination MAC address is R3A. From here to here, source MAC address is from here to here, source MAC address is R3B, destination MAC address is BA. Right? So remember, MAC address keep changing. It's hop to hop. But IP address start to end doesn't change. Only place it can be changed is when you're leaving your network, that is a private address to public IP address. But they have not mentioned that these are private IP addresses. So therefore, we can all assume that these are public IP addresses. So remember, if you have a private IP address, and then when you leave your data packet, then your private IP address is taken out and the public IP address is assigned. So otherwise, throughout the journey, it is your source IP address and destination IP address. Okay. Right. So therefore, what is the answer? So when it leave R1, what is the destination MAC address? Leave R1. So when you leave R1, destination MAC address is R3A. Capital R3, simple A. Right, R3A. Right, next question. What was the destination IP address on the packet P when the frame carrying P left R1? Right, left R1. That is when you leave R1 somewhere here, this journey. Remember, throughout the journey, IP address doesn't change unless you are leaving your private network to public network and if you have private public mapping. Here they have not talked about private IP addresses. So therefore, throughout the data packet source IP address is this address, destination is this one. Are they talk about the destination or source? Destination IP address. Destination IP address is always 192.168.3.1. 192.168.3.1 because it's always that. Okay. Right. Next question. Right. Now we are done with first one. I think all 3 years we have a similar question. Similar question as the first one. Or part of that is like that. Right. Second one. We did this theory part anyway. Anyway, we'll just rush through it only. Because we have discussed these things in the class. Write down the main objective of the transport layer. Remember, transport layer is above network layer. Physical, logical link or data link, network, transport. Then session, blah, 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 and then finally the application. If you go for 7-layer application. Right, so remember this is your physical connectivity. This is MAC address, data frames, switching. This is routing, IP addresses. And transport layer is giving you the reliability, aware expected level of reliability. If you need more reliability, TCP, but if you prefer efficiency over reliability, UDP. So this is where you give you the expected amount of reliability. Connection, reliability. Connection is also there. That is why we have port number. So you need to explain that. So it provides the expected amount of reliability to the upper layers, especially the ultimately for the application layer. Right? Reliability, connectivity, that kind of things. Right? Main objective is reliability and connectivity, providing that to the upper layers. Provide efficient, reliable. Remember, it's reliability versus efficiency. It's a compromise agent. The more reliable, less efficient. If you can compromise, if you can compromise little bit of reliability, you can achieve efficiency. So therefore, you need to mention both. So TCP, more reliable, less efficient. UDP, more efficient, little bit less reliable. Right? So your application protocol will decide which one you want. Like DNS will go for UDP, HTTP, FTP, SMTP will go for TCP. Okay. If you have understood, this paper is super easy. Actually, you can go for A plus. But if you have not understood, you try to memorize things. Now you are in trouble. But one lucky thing is your questions, exam paper, all 3 years, it's sort of the same mold. කටපාඩම් කරන්නට පොඩි chance එකක් තියෙනවා එක mold එක paper එක අතර තියෙන paper එක මාරු කරොත් එහෙම බෑ ඒගොල්ලෝ අනාථ වෙනවා. Structure එක මාරු කරොත්. Okay. But for last 3 years, it's pretty much the same mold. Because now we are more concentrating on the exams rather than understanding, because we concentrated our first 3 months understanding the subject. We did not focus much about the exams, because if you understand, you can face any exams, you can do any practical things. If you just concentrate on exams, after exams, all your memory will be short-circuited, because your objective was exams, not understanding concepts, building competencies. You don't have any future plan to develop something, build something. Right. B part. The transport layer obtains services from the network layer. Right. Transport layer, yes. Network layer is the lower layer. From lower layer support the network layer, support the transport layer. Then transport layer support the upper layers and provide services to the application layer. Is ultimately application layer. This task is done by transport entity. Yes, we call it transport entity. That is a logical concept we use. Write down 2 locations where the transport entity can be found. So remember, transport entity is end-to-end. So it is a transport layer that start thinking about end-to-end communication. Physical, link, network, hop to hop. Your routers, switches has something to do. But transport and above, routers, switches has no concern for that. It's only about two ends. Two ends. Connection is between the two ends. Port numbers are source and destination. So your routers will not look at the port number, but IP address, but not port number. Right? So this is so therefore these are implemented where? To end computers. So transport entity is implemented in the end computers, not routers and switches and blah blah blah. So it can be your network card, respective network card. So it can be implemented by OS, okay, or any other separate utility, okay, and so on, right? So I think there were about 4 or 5 firmware straight mentioned in your note, right? Yeah, operating system, network card, any other utility or library packages, because these are end to end or mixture of hard NIC and your OS or utility. Draw a diagram depicting the logical relationship of network, transport, and application layers, including transport entity. So this is mentioned in your slides also, right? So you need to show the 4 layers and also binding. So remember, you need to show network. You don't need to show so physical, right? Network, you don't need to show logical and physical. Network, then transport, and application. So the binding is between transport to transport. So port numbers, source port number, destination port number. Right? And you can show that we have either TCP or UDP and so on. Right? And this support this, we get the help from this. And this is given to your application layer and lower layer support you. So likewise, there was a standard diagram in your UCSC note as well as our note. So use that diagram. Just draw that diagram. Okay. So you can see transport entity. So it is connected to the application layer top, network layer bottom. And this transport entity is the one that is implemented by your network interface card, OS, and any other utility. And it's very important to show these two, that is transport address, so the TCP or the port number, and the IP address. Network address is the IP address. So network layer IP address, others talk to the port number. Transport address is port number. Okay. And this is called segment. Remember, segment. So this is transport to network interface. This is transport to application interface. Of course, in 4-layer architecture. Otherwise, it is a session. But remember, this is standard diagram showed in your note. So try to draw the diagram as much as possible exactly. Because this question can be repeated. Because this is a very famous diagram. Right. What is the purpose of using port number in the transport layer? So port number identifies the running program or running process. Source port number, source running process. Destination port number identify the destinations running process. So then the data packet will be given to the correct running process or running program. So you need to explain that, okay? Like if it is a web server, usually it is 80 port number and so on. Like you can give some examples. So remember, IP address uniquely identify the machine. Port number uniquely identify the running program in that machine. So therefore, without port number, your OS data packet will reach the destination, but then the destination OS don't know what to do with this data packet. Should I give it to the email server or running web server? If you have multiple, or running database server, if you have multiple network services. So port numbers are used to identify these transport endpoints uniquely. Endpoint is a endpoint programs. Can a domain name be mapped into two different IP addresses? Justify your answer. So this is a very famous question in networking. So I highly recommend you to do at least, not at least, do all the past papers available, because network subject syllabus is not much change. But in new syllabus, there is a lesser emphasis on certain aspects. So those things you can skip. But subnetting, these concepts, OSI architecture, these things have not changed. Because don't expect that because last 3 year papers are of the same mold, your paper will be the same, right? So you know what happens to your semester 3, right? So semester 3 paper was not that difficult. All of a sudden the structure was changed. Sort of a not the questions are not from the same structure. Actually, those exam papers were not difficult. But some students they just do 2 3 years past papers and expect that same type of paper. So we never know, right? So this year maybe different structure papers. Okay. Right. So this is also a very famous question. So can we model map domain name to multiple IP addresses? Yes. So that means say your abc.com So that means if someone access abc.com, we have redundant servers. So this is also hosting the website or web application. This is also hosting the web application. This is one IP address. This is another IP address. So then your request can be sent to either this IP address or that address because both are going to serve. So when you have highly scalable applications, this is possible. Sometimes it is only one IP address. Internally, there's a load balancer sending to different machines. Or you can map it into multiple IP addresses. Right? Multiple means of 2, 3, 4 IP addresses. So then one of the IP address can be used. So then it's sort of a balance in the load. Or depending on the location, your nearest IP address will be given. Say some DNSs will say X IP address. Some domain name systems will say Y IP address. Why? Because Y is closer to, say, Europe region. X IP address is the closer when it comes to Asia. So then when I type abc.com, if I am from Asia, I might be served by one server. And Asian region DNS servers will have that. European region DNS servers may have slightly different one because they can be served from machine closer to Europe. So likewise, one domain name can be mapped to many IP addresses. And simple answer is yes. Okay. So that means you need to add multiple A records. Remember, A records map domain name to IP address. You can have multiple A records. Other thing is if one when a server send request to one IP address, if it is not responded, it can send it to the second IP address. That redundancy is also there. So those are possible questions, okay? Because you get two IP addresses, DNS resolution. So then if first one doesn't respond, you have another option to send your data packet to a second IP address. Maybe when first server is down, but the second server is up. Okay. Right, next one. Draw a diagram depicting the architecture of an email system, including the main subsystem. So you need to explain mail client, mail agents, the two mail clients, two mail agents, the two mail servers, and also show the software running and also the protocols. Okay, right. So these are standard question. Make sure you show the SMTP. Here you can say IMAP. Here you can say IMAP and so here SMTP. Assuming you are sending email this way. Here SMTP. Here POPO IMAP. So this is senders use agent, senders uh, transfer agent. This is the senders mail server, receivers mail server or message transfer agent, receiver, and receivers use agent. Use agent is your email client like Outlook. This is senders use agent. Okay. Just show the here to here SMTP, here to here SMTP, but here POP IMAP. So try to show everything so that you get the full marks. Right, that's it. So that's it about 2021 paper. Okay, so let's continue. Right, so now we move on to 2022 paper. Okay. Okay, just give me 1 minute. Right. Right. So we can see it's similar question, right? So that is why I told you that if you get a similar question, of course, anyone can pass this exam. Right? because if you have done proper past paper, then the next paper is also like that for the last 3 years. Right. Again, they have given you some details. The configuration of the machines are given below. Again, let's write it. Machine A interface is ETH0. ETH0. MAC address is MA0. And IP address is 8811. Subnet mask this time they have given. So therefore you need to calculate what is 192. I will be using my calculator, but just check with the calculators are allowed, okay? Right, 192. One nine two means 2 1s and 6 zeros. That is slash 26. Slash 26. Okay. Right, next one. B. B has two interfaces. MB0, MB1. So what is MB0? What is MB1? Right, because MB0 is 88110, so it must be some this side because that is 881. 88110. And it is ETH0, right? ETH0 and MAC address is MB0. I'm just referring to this interface, okay? And they have not given us the subnet mask, so therefore we can't write the slash value also. So then the B, other side, ETH1, this is this side, ETH1 or MB1. MB1. So remember this is this, okay? Let me ETH0 MB0. ETH0 MB0. That is this one. Okay, so this is this one. MB1, ETH1, and it has the IP address 192.168.10.254. And it is 255.255.255.0, that means slash 24. Okay. So then C, of course, C has only one interface, ETH0 or MC0 MAC address. IP address is 192.168.10.1, again slash 24 because 2550. Right. So those are the details available. What is the destination MAC address in the data link layer frame containing P in LAN 1? Justify your answer. Containing P. Yeah, an IP packet P is sent from machine A. Right. So this is your starting point to the machine C. So that means through machine B. Okay. So this is where you get the data packet. Okay. From there to there. Okay. From there to there. Right. So let's read the question again now. What is the destination MAC address in the data link layer frame containing P in LAN 1? In LAN 1, it is basically this MAC address because from here to here, it's not IP address. So because this is one subnetwork, this one subnetwork and this is another subnetwork. Actually, this one has only two subnetworks. Right? What are the two subnetworks? So including this interface, this is one subnetwork. And including that sub interface, that is the second subnetwork. Okay. I will just erase it because it's too much of things. Right. So therefore, destination MAC address will be this MAC address. That is MB0. MB0. Right. MB0. And you need to justify, right? MB0. You need to justify. Justification you need to do, right? You guys are not now kids. Right. B. What is the subnet mask of IP address assigned to the interface ETH0 of B? Justify your answer. ETH0 of B. ETH0. Right, this ETH0. Sorry, ETH0 of B is this one. ETH0 of, sorry, this one. Yeah, ETH0 of B. So this one subnet mask must be same as this subnet mask because this is one network. So that means this is also /26. Actually, we got /26 from where? Subnet mask itself is there, right? 8811. So the subnet mask must be 255.255.255.1. You need to tell that this is one subnetwork. So therefore, they have the same subnet mask. So subnet mask of machine A or ETH0 is 260192. Therefore, this one subnet mask is also 255.255.255.192. Right. And you need to justify. C. What is the source IP address P when it goes through switch 2? Remember again, source IP address won't change throughout. Source IP address is 8811 throughout. Right, 8811. You need to explain that it doesn't change. Okay, it doesn't change. Right, D. What is the source MAC address on the link layer frame containing P when it reaches C? Right, when it reaches C, what is the source MAC address? Right, when it reaches C. Right, so reach C means here. So when it reaches C, source MAC address is this MAC address. This MAC address is MB1. MB1. You need to explain, okay? MB1. Right, that's it. Question number 1. You can see it's pretty much the same question. Right, question number 2. Aloha and slotted Aloha are two multiple access protocols. Yes, we discussed both Aloha and slotted Aloha. Right. So Aloha, there's a high chance of collision. Slotted Aloha, try to reduce the collision because at the beginning of the slot only you can send in slotted Aloha. Aloha, you just again send it. Okay. So you need to explain that slotted Aloha, there are time slots. You can refer to the note because we discussed that, and also the recording that we discussed this concept. But in slotted Aloha, if there's an initial busy, you only send it at the beginning of the new slot. But again, there's a possibility of collision, but at least it will be reduced. Okay. Right. Slotted Aloha has time slots and all the transmissions start at the beginning of the time slot. Beginning of the time slot. So if you need more details, refer to that our note and also recording. Write down the maximum throughput of Aloha and slotted Aloha protocols. Those are given in your note. What is the throughput for Aloha? What is the throughput for slotted Aloha? Right? So that you should be able to refer from your note. Okay. Right. B. Following diagram shows the architecture of the electronic mail system. So architecture is given. Name A, B, C, D. Okay, that is kid stuff, right? You can do it by yourself. Write down major functionality of A. A is sender's agent, mail agent. Like sender's mail agent, something like Outlook, Thunderbird. Okay. You need to explain. And so it's used to read and send emails. It's sender, I mean, according to this diagram, right? But same mail agent can be used because when you get the reply, it is you can use it for read mails also. What is the purpose of E? E is the mail transfer agent of the receiver. So it keep the mails, right? Keep the mails until D connect, mail agent connect. So it can keep the mails. And it can keep the copies of sent mail as well, sent items. Okay. Store or keep the emails that is received for a user. Who is responsible for maintaining E? So that is the responsibility of the mail transfer agent or simply the mail server. Okay, mail server. Mail server or mail transfer agent. How the server identified whether the recipient is using ESMP, extended SMTP, or SMTP. I think that is called hello and hello in reverse order, right? If it doesn't respond to hello, sorry, EHELO, I think that is how it is done. I can't remember exactly whether first hello and then the reverse or first reverse hello. I think first hello and then reverse hello. We discussed that. Okay. Yeah. First you send the EHELO, uh, right? Sorry. In extended SMTP, we send EHLO. And normal SMTP, we send hello. And usually what happens is we first send EHLO, and if it doesn't respond, that we know that it is not ESMTP, it is normal SMTP. So then we send hello. So all these are explained in your notes. Okay. List 2 extension used in ESMTP. Right. So we discussed that ESS rather than SMTP, ESMTP has a few more features for managing your uh, mails, right? So those are you can mention, okay, straight from your note. Following diagram shows the packet nesting and encapsulation of payloads at each layer of OSI model. Yes. So this is layer 4 is data is encapsulated by layer 3 and layer 2. So layer 2 is basically link layer, network layer. Okay. So remember in 4-layer architecture, layer 4 is application layer, right? Layer 4 is our application. Link layer, physical layer, link layer, network layer. Sorry, not network layer. Link layer, network layer, transport layer. So layer 4 is transport layer, and this is the application layer. 5-layer architecture. Right. So what is the question? List PDU, protocol data unit names of each layer. Right. Protocol data unit. Layer 2, frame. Layer 3, packet. Layer 4, segment. Application layer, of course, there's no specific name. Frame, packet, segment. Right. Straight theory. List a relevant protocol for each layer. So frame, For layer 2, there's no such protocols. Maybe we can say MAC. Obviously, layer 3 IP, layer 4 TCP or UDP. Layer 2, there's no specific protocol. Maybe MAC, I don't know, MAC is it can be considered as a protocol. Yeah, so because there's no protocol, they have considered it as Ethernet. If they ask about, actually, it's not actually a protocol, it's a technology. Right? Actually, there are no specific protocols for layer 2, but if they ask, again, just mention Ethernet as a protocol, but actually Ethernet is not a protocol, but just consider it, okay? Mention two important information that is included in the layer 4 header. So the source port number, destination port number, okay? And I think we have few more. You can refer to the note. I think we have few more that is added by transport layer, okay? Transport layer. But definitely is source port and destination port. Right, that's it about 2022. Right, we straight away go to 2023 paper also. Now we can go much faster. Right, pretty much similar question. Should I do it? I don't think so, right? You should be able to do it by yourself because answers are also there. Okay. But this time it's IP addresses are not given, so therefore it's even easier. Okay, let's do it. This is even easier question. An IP datagram P is sent from machine A to machine C. That means go through this. In the network depicted in the following diagram, machine C has successfully received P. So that means data packet has reached C. P is encapsulated in the link layer frame F1. Right? So your packet is encapsulated as frame in LAN 1. In LAN 1, it is called frame 1. Okay? LAN 1, it is called frame 1 because in LAN 2, it will be a different frame. Just try to put it into the diagram itself. Okay? And F2 in LAN 2. In F2, layer 2, protocol data unit is called frame 2. Because why it is two different? Because MAC addresses are different. The user X is logging as the administrator of the machine C. So user X has logged into this machine as an administrator of the machine C, and he can observe and analyze all the link layer frames that come into C. So that means he can analyze this frame F2. He can't see F1. He can't see F1 because this is a router. It's a different network. So remember, this is one network. This is one network. And the other one is this one. Therefore, there's no overlapping. So the this router has two interfaces. Okay. Right, I erase that. Right. So what is the next question? Right. Is it possible for X to determine MAC address of the interface of A? Interface of A means this MAC address. By analyzing frame 2, no. Your frame 2 has source MAC address as this, destination address as this. So your frame 2 has no idea about A's MAC address. So the simple answer is no, and you need to explain. Okay. because here the source MAC address and destination MAC addresses are this and this. Is it possible for X to discover the subnet mask of LAN 2 based only on the information available in F2? Right? Based on F2, can X determine the subnet mask of LAN 2? Now you have the frame. Okay. You have the frame subnet mask of which LAN? Subnet mask used in LAN 2 based only on the information available in F2. LAN 2 is the same thing, right? Same LAN, right? Yeah, LAN 2 is this. But the thing is, yes, so this guy must know the subnet mask, obviously, because you are so part of the subnetwork. But you get the subnet mask not by your data packet because your data frames or data packet doesn't have any information about subnet mask. So they contain only MAC addresses, IP addresses. So subnet mask is something we specify separately. Your DHCP server will give you the subnet mask. Or you configure subnet mask statically in your machines and routers, route interfaces. So therefore, by looking at data packet, because data packets, they don't carry subnet mask. They carry the source and destination IP addresses, the two endpoints, and source and destination MAC addresses if it is a data frame. Okay. So that means your IP data packet is also look at as data frame by the other layer 2. So therefore, by with available information, there's no way you can talk about the subnet mask because it is something you get it from your DHCP servers or manually configured. Right. So let's see B. Yes, no. Subnet mask is not carried out by IP packets. It is not a field in IP header. Subnet mask is not a field in IP header. So that is your DHCP server give it to you, assign it to you, or your network interface has been configured statically. Remember when we configure, we give the IP address, subnet mask, and also default gateway, DNS server, right? So those are the four things we assign. If LAN 1 and LAN 2 use different link layer protocols, that is possible with different frame formats. Is it possible for fee to receive C? Justify your answer. Yes, that is possible. Maybe this one is Ethernet, this one is Wi-Fi. Okay. Of course, Wi-Fi will not have physical switches. They can use different topologies and so on. It's possible. For me, it's possible. Yes. Link layer protocol LAN 1 is used only to pass to B. Then P is extracted by F1 and blah, blah, blah. Yes. That is how the dissimilar network can be part of your internet also, right? So just because your network topology or the technology is different doesn't mean that you can't connect to the big networks. That is why consistently you have IP address, IP packets. Frames can be different, but packets structure is common. Is it possible for X to discover the IP address assigned to LAN 2 interface or B by analyzing the information in F2? Justify your answer. Is it possible to X to discover IP address assigned to LAN 2 interface or B? LAN 2 is this. Okay. So yes, your data packet is coming to you, right? So that is your IP address. IP address assigned to LAN 2 interface. IP address assigned to LAN 2 interface. Oh, that is this IP address, right? This IP address, LAN 2 interface. No, we don't get that IP address, right? Because it's the source IP address and your IP address, source and destination. You don't get the intermediary IP addresses, but you get the MAC address of that. By giving the MAC address, maybe you can get the IP address by address resolution protocol, but something like that is not mentioned here. So by looking at the data packet or data frames, I don't think we can find the IP address of this machine, this router, because your data packet has the source IP address and destination IP address only. But MAC, yes, but not IP packet. I say no. Yes, no. Right. Source IP is P. In P is IP of A, and destination IP is the IP of C. No other IP addresses are in P, and no other IP addresses are in F2. Right? Intermediate IP addresses are not mentioned. Intermediate MAC addresses are mentioned on that segment. Right? So therefore, answer is no. You need to justify. Describe the use of address resolution protocol, ARP. That is where you can send your IP address and get the MAC address or vice versa. When forwarding P to the machine A, machine C, forwarding P to the machine C. Now from here to here you can go, but from here to here, right? How to explain that? That is my problem now. From here to here you reach. Now, why do we need address resolution protocol? Now we are in this router. And this router will say go this way. Then I need the MAC address of this one. Maybe your router can send the IP address of this one and get the MAC address because you need the MAC address. I think maybe something like that. Because otherwise, how can I know this MAC address? Is it something like that? Usually, address resolution protocol is to give IP address and get MAC address, or otherwise, reverse. Right. So, what is the answer? P contains the destination IP. B should find the MAC address corresponding to IP to encapsulate in F. B uses ARP to resolve IP to MAC. Yes. So you send the MAC address, IP address, then because you have the destination IP address, you can get the MAC address. But that MAC address is, but here, right? But you don't have the IP address of, that is little bit fuzzy. P, now, where do we do this? Describe the use of addresses protocol at B. At B, when forwarding P to the machine C. Forwarding B to the machine C. So that means at this point. At this point. Yes. Now you have the destination MAC IP address. Anyway, destination IP address is always there. So by giving the IP address, you can get the MAC address. But the thing is, how do you know that it is the final part? Final part. Because there can be another router, another router. So that is a bit of debate. How do we know this is the final destination? So if it is the final destination only, this IP address is your data packet address. Anyway, that one is little bit fuzzy. But that is what explained in the note, in the answer. Anyway, little bit fussy that answer for me, okay? Right, so that is the end of the question number one. Preamble is the first component in Ethernet header. Yes. So if that shows, that gives you that it is the starting. It's a regular bit pattern, right? I think 1010 or something. Describe the content of preamble and the purpose of it. So it marks start of a new data frame. You explain that exact bit pattern and the width of that pattern. I think few bytes, okay? Right, 8 bytes each containing the bit pattern this 10101010 and ends with two ones. Last bit byte has two ones. So then your switch and other devices knows that okay, that is when you're getting 10101010 is a new frame. And when you get the last two ones, okay, that is the end of the preamble. Okay. Redundant links in the link layer can create loops. Right? Redundant links means you are going, loops means you are coming back to the same. Say this router route here, of course there are some other places route, but somehow you come back to the same router. So that means it can be repeated. So that means your data packet is keep going round and round. Right? Loop. Describe a problem that occurs when loops are presented in the link layer. So that means your data packet will not reach the destination. Rather, it will just going round and round the loop. So how do you overcome that? Okay. So try to use the exact word that is called broadcast storms, link saturation. Solution is spanning tree protocol. So spanning tree protocol will resolve it to a sort of a tree because tree graphs have loops, but tree doesn't have a loop. So therefore, that is why we call it spanning tree. Right? So you learn about spanning trees in data structures and algorithms semester 3. It's not new thing. So every graph you can create spanning trees, and also you can create minimum spanning tree. So that guarantee that because spanning tree is not a tree graph, you guarantee that no loops. So okay, you can route as well as no loops. In traditional switch architecture, what is the plane responsible for packet buffering and packet scheduling? So that is done by low layer, right? Data layer. Traditional switch architecture, right? Not the modern software based architecture. Not modern software oriented networking. UDP is a popular transport layer protocol. List down 4 fields in the UDP header. So you must remember those things, right? What are the key component in UDP header, key component in TCP, and also header sizes. Right? Definitely source protocol, source port and destination port is there. That is always, right? You need two more. I can't remember what are the other UDP has. Of course, TCP has a lot of things like urgent point and blah, blah, blah. Okay. What are the other things? Can you remember? Checksums. Yes, I think UDP. Do we have checksums in UDP? I think yes, basic checksum is there. Okay. Right. What are the other things? Yeah, UDP length, UDP checksums, and so on. Right. So just make a note of all these fields because examiner has asked it in second paper. Second paper means lot of marks. Okay. Right. Describe RPC. We did this question. Right. Remote procedure false. So client stubs, then server skeletons and actual server. You need to explain each and every step. And we did discuss this under enterprise application also yesterday. Right, same diagram, okay? Like client stubs, client stub communicate with server stub or server skeleton communicate with server. So just try to draw a neat diagram. This OS, two side. This is client CPU, server. I don't know. The CPU is a good question thing, but anyway, this is client and server. Okay, right. That's it. Right. So we did. I think this is the easiest paper in a way when you consider the last 3 years. But maybe they can go for more serious questions because there can be more serious questions like if you look at about 5 years, 6 years ago papers, there are plenty of serious questions. Even A-level ICT question is super complicated than this. Right? They will ask you to decide IP subnet mask, break it into subnetwork. We did that kind of questions in the class, but I'm pretty sure this time they will ask that kind of question. That means something like this. We did that kind of question in the class, so therefore I don't want to do it again. Computer networks. Subnetting. Right? Break it into two subnetwork, four subnetwork. Okay. So those are the type of question you used to get about 4 5 years, but last 3 year exams were pretty simple. Right? So this kind of questions. Right? This kind of questions. Yeah, you gradually break it into subnetworks. And so make sure you go through this because I feel like you will get this kind of question this year. Okay. So especially go through that recording and that particular recording where we discuss about how to break it into subnetwork like this. Okay. Equal size or different size. Maybe equal size. Because A-level ICT, every year you get this kind of question. Every year. Right? Not like your questions are like kid stuff. Right. So now we have officially finished your network subject. We did not discuss, we have to discuss one more MCQ, right? One more MCQ is there. Right. So we'll take a break. After the break, we'll discuss the MCQ and finish. Okay. Now it's 8:50. We'll start at 9:10. Right, 9:10. 20-minute break because I'm also right. So let's go through. Which sentence among the following describes the purpose of VPN? So remember, VPN means virtual private, right? So secure, yes, the objective of this is to make it secure, but VPN technology itself has no guarantee of security. So security, you need to get it through IPsec and other ways. So therefore, VPN itself is make your connection private. So that is a very famous question. The security comes from other configuration. Actually, VPN facilitate you to configure security. So therefore, answer is not secure communication, private communication, because virtual private network. So security comes by configuring IPsec and so on. So that is a very famous question in computer networks. Right. Second one. B. The medium access control or MAC sublayer It is part of the logical link layer. Is responsible for dealing the additional issues caused by broadcasting network. What is the layer in the OSI reference model that contains the MAC sublayer? So MAC sublayer is in the logical link layer or link layer. So link layer is subdivided into this, okay? So therefore it must be logical link for the data link layer. C. Super easy question. Third one, what is the maximum number of bits that can be sent within a second over a channel with data rate of 1 kilobit per second? Right? So data rate, data rate is 1 kilo. Now here kilo means 1000. That is 1000 bit per second. Right? What we need is maximum number of data rate. Remember we did this kind of questions. Okay. So under physical layer. Sorry, data link layer. Right? No, physical layer, right? Physical layer. Right? Computer networks. Data transmission channel capacity equations or bandwidth equations. So this is the maximum data rate in noiseless channel. 2B log 2V. V is number of discrete signal level. Of course, in binary it is 2. So then log 2 is 1. So therefore maximum data rate is 2 times bandwidth for binary communication, binary digital signal communication. So maximum data rate is 2 times bandwidth. So here the bandwidth is given. Like bandwidth is given as 1000. So therefore maximum data rate is not 2000. No. What is the maximum number of bits that can be sent? Sorry for that. Okay. Right. So the data rate is given, not the bandwidth. Right. So it's a very, I thought it's a bandwidth is given in hertz. No, it's very easy, right? Channel with a data rate of 1 kilobit per second. That means within 1 second, you can get 1000 bit, right? 1000 bit. So the answer is 1000 bits because I thought we need to do I thought they have given you the bandwidth or the frequency. No, straight away they have given the data rate. 1 kilobit per second means in 1 second, 1 kilobit. Here kilo means because bits are not, these are not bytes. So therefore 1000 bits. That is simpler than what I thought. A. We did not discuss Hamming codes, right? So I asked you to remind me. Right. So we'll take Hamming code last. Okay. Anyway, uh, so what is the Hamming distance? How many bits are different, right? How many bits are different? So therefore, so these bits, these are different. These are different. These are different. Others are not different. So therefore, Hamming distance is 3. How many codes are different? So fourth one, C. Right. Fifth one. Maybe we can do Hamming codes in the next class. Okay. So just I will do it in next class. But for this, I told you how to do it. How many bits are changed. But how to add the Hamming codes and blah, 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 we will discuss in the next class. Okay. While we discuss, because we need to discuss a little bit about the EAD, Enterprise Application Development. Then I will take the Hamming code also before moving to project management quizzes, okay, past papers. Right, fifth one. What is the relationship, if any, between flow control and congestion in networks? So the idea is to do the flow control effectively so that the congestion is minimum. right? So it's common sense also. Common sense also, right? So the answer is C. Flow control is mechanism used to reduce the congestion. Remember, only one answer is correct. 6. The service provided by layer K of the protocol stack is used by which of the following? So layer K services are used by layer K plus 1. Lower layer support the upper layer. K plus 1. Okay. It has, yeah, only one answer is K plus 1. Same was right. So the support is given to the same machine. Same machine. So the 6 must be D. D. 7. This one need that formula. And this one we have given the bandwidth. And it's a noiseless, ideal. 1000 kilohertz means 1000 into another 1000 because kilohertz you need to convert into hertz. Another 1000, that is 000. That is bandwidth. And remember here you get 2B because binary B is 2, log 2 is 1, 2B. Right? No, it says 8 discrete levels. No, sorry, we need to take B. So therefore, maximum data rate is 2B log 2V. 2B log 2V. 2 times bandwidth is this 1, 2, 3, 4, 5, 6, 10 to the power 6 into log 2 V. V is 8 discrete levels. That means it has 8 levels, not binary, octal signal. And log 2 8 is 2 to the power 3. Therefore, it is 3. Then 3 into 2 is 6 into 10 to the power 6 kilobit. So take a bit per second. Right. So we will answers are in kilobit. So therefore, we'll take 10 to the power 3 again. 10 to the power 3 is kilo. So then another 3, that is 6000 kilobit per second. kbps, simple B. 6000 kbps. Seventh one, E. Eighth one. So what is the reason to have twist in twisted pair cables? So twist are to reduce the what? Reduce what? Enable the cancellation of radiation from the wires to reduce the noise. In a way, yes, radiation. Okay. To improve appearance, no. To reduce the total length, no. Actually, when you twist, total length increase. To reduce the material use, no. When you twist, you need more material. To amplify the signal, no. It's not going to amplify the signal. It reduces the noise. How to reduce the noise? So the effect of radiation from one is cancel out by the other one. That is why we twist it. Otherwise, it will get exaggerated. Right. Answer is A. Ninth. It is given that electromagnetic wave has the wavelength of 3 meter, lambda. Lambda is 3 meter. What is the maximum frequency that we can have? That is frequency. Remember, we can use speed dash 3 into 10 to the power 6, right? 6 or 8. Right. We did this formula. V C equal F lambda, right? Yeah, C equal F lambda. Let me take that equation. කොහෙද අපි එක් කරේ මුලදී? Yeah, V equal F lambda. V equal, right? V means C for us. Right? V means C. 3 වැඩි කිරීම 10 6ද 10 8ද ගන්න මතක නැහැ. ඒක දෙන්නේ නැහැ exam එකේ. 3, okay, what is ඔන්න මතක තියාගෙන යන්න දෙන්නේ නැහැ. Speed of light. Because waves go at the speed of light. 10 8යිද? Yeah, 8. 10 to the power 8, right? 10 to the power 8. Not 6, 10 to the power 8. So therefore, maximum frequency we need. So frequency is V divided by lambda. V is 3 into 10 to the power 8 meters per second divided by lambda, 3 meters. Meter to meter get cancelled. So frequency is per second. Per second means hertz. At 3 to 3 get cancelled. 10 to the power 8 hertz. Per second means hertz. But this has given, they have given it in 10 to the power 3 is kilo, 10 to the power 6 is mega. 10 to the power 6 into 10 to the power 2 or 100. 100 megahertz. Remember, hertz, it is 1000. Hertz, bits, only byte is 2 to the powers. 2 to the power 10, 2 to the power 20. So answer is B. 10. Sharing network bandwidth dynamically according to the short-term needs of host. Short-term needs of the host means statistical division multiplexing. Statistical division multiplexing. So short-term demands based on the short-term demand, that is why we need the statistics. We can adjust, give more and less. C. We discuss those, okay? Right, this is the easy question. Which of the following represent the correct ordering of prices of the media? Prices, definitely not twisted pair or coaxial cable. So it must be C. C. 12. What is the cut-through switch? Right, cut-through switch we discuss. Right, cut-through switch, I think it provide electricity also, right? Remember we discussed that somewhere. No, cut-through switch, don't keep the data, right? The moment you get it, you forward it. You don't keep it in a buffer, right? I think we discussed that somewhere. Uh, we discussed that somewhere. Yeah, the moment you get it, you send it. I think we discussed that under software-defined networks or something. I can't remember exact place. But definitely we discussed that somewhere, okay? Cut-through switches. It's a very famous question, even in A-level ICT. Even in A-level ICT. So let's see the answer. 12. Start forwarding as soon as destination header field has come, before the rest of the frame has arrived. So it's එන ටික ටක් 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 ගාලා යවන්න. B. Okay. That is why we say cut through. 13. What is the technique, algorithm used by bridge to create loop-free forwarding paths between? Loop-free forwarding path. ඒක නම් මගේ ඔළුවට එකපාරට එන්නේ නැහැ. Loop-free නම් හැබැයි spanning tree තමයි ගොඩක් කරන්නේ. Spanning, because spanning tree means you convert graph into a tree. Why? Tree has no loop. My gut feeling says C. Because spanning tree can loop නැතුවත් යවන්න තමයි. Yes, E. You can see spanning tree algorithm is one of the favorite of the examiner. What is the size of the checksum field of the Ethernet frame? ඒක නම් මම මතකෙන් තමයි කියන්න ඕන. Right? ඒක මතකෙන් කියන්න ඕන. ඒක ඉතින් මට කරන්න දෙයක් නැහැ නේ. ඔබ මතක තියාගන්න. 32 bits. Right. In P persistence, remember we discussed one persistence, P persistence. So P persistence means when there's a collision, right? You try to send it, but not always you send it. Sometimes you give it to the others with P probability. You keep listening for the next availability. But though you keep listening, it doesn't mean that you always send it. Right? If it is one third of the time you send it, 2/3 of the time you don't send it. So that is the best compromisation between too much eagerness or too much generosity. So P persistence is middle ground. And we discuss about P persistence. Station checksum transmit the probability of 1. No. 1 means you always send. Station transmit without checking whether no. Station transmit with the probability of P if it finds the channel is free, correct. So P depends on your configurations and traffic level. So C. Which of the following is not a field in UDP header? Definitely source port, destination port must be there, checksum must be there, right? So UDP don't care about MAC addresses, right? Anyway, MAC address is not transport layer concept. MAC address is link layer concept. So the length is also there, I think, right? Yes. So MAC address is not nothing to do with the UDP because MAC address is layer 2 concept. So therefore answer must be A. A. 17. What is the library protocol in RPC which represent the server procedure in client's address? Server procedure in client's address means server procedure in client's machine. So that is client stuff. Client stuff. Super easy question. 18. Which of the following is not a management functional area defined by network management by the International Standard Organization? So there's a separate note on that, right? Big note, I gave you a summary note, right? Because that note is too big, right? So remember management, network management, management functions, right? Fault management, security management, performance management, infrastructure management, configuration management. Which of these are management? අපිට මතක නැත්නම් මටත් මතක නැහැ අතන දැන් නම්. management වැඩක් නොවන එකක් කියන්න බෑ. Not a, right? Security, performance, infrastructure, configuration. Is security management? Infrastructure management. Anyway, I can't remember. Okay. Okay, let's see the answer. Is it infrastructure there? Yes, infrastructure management. Okay. Right. So just you need to remember those things, right? I gave you separate note on that. That is topic number 7, right? Network management. Right. Fault management. These are the tasks. Account management. These are the tasks. Configuration management. Performance management. Security management. Right. But the question is not, but these are all management, right? Fault management, account management, fault management, account management, configuration management, performance management. Performance management is there, configuration management is there. Then security management. Yeah, that is the last one. So then the answer is correct, right? Security management is there. So there's nothing called infrastructure management. Right, 19. Which of the following is limitation of private network built by the connecting company computers and lease telephone lines? So if you use lease telephone line rather than the internet itself, the issue is your lease lines have restrictions, right? Your lease lines have physical restrictions, bandwidth restrictions, and so on. So the answer is scalability. You can't scale it. Scale it. Because it's you use lease line. Right? Dynamically you can't change. Right? Or you are bound physically to that lease line if it is wired line. So you don't have that much of flexibility when it comes to lease line. So therefore, these days people are not much interested in lease line, but you can get high bandwidth and internet. That is better flexibility. High bandwidth, but normal internet, not just the lease. Right. 20. A machine in a network is configured with IP address this and the mask of this. What is the broadcast address? Super easy question. Kid stuff. Right. So first convert 192 into binary. Right. 192 into binary. That is your starting point. That is two ones, 216. That is second bit. Second bit. Okay. So then convert 139 into binary because we are interested in the last octal only. You don't need to convert these into binary, but 139 convert it to binary. If calculators are not allowed, you need to use your normal repeated division by 2. 139. That is 1 000 1011. 1 000 1011. So this is the IP address, but this is where the separation. So what we need is the broadcast address. Broadcast address is all these are 1, but these 1 and 0 will remain because that is not our control. Subnet ID is all 0. Broadcast IDs, these are all 1. But you can't touch this because we have control over this because of the subnet. Right? What is this that number? 1, 2, 4, 1, 2, 4, 8, 16, 32, 64 minus 1, 63. Then this one, 1, 2, 4, 8, 16, 32, 64, 128. 191. Answer is A. Broadcast address is A. 21. A machine in a network is configured with IP address 192.2.8 blah blah blah. What is the CIDR notation that illustrates the machine's IO? So just convert this into base 10. 240. 240. That is 4 ones, 4 zeros. So therefore, CIDR notation is 888 24 24 plus 4 28 slash 28. C. 22. Which of the following statement is correct about software-defined networks? That is theory. SDN is network simulator. No, it's a real software. It's real networking mechanism, network configuration mechanism. SDN refers to collection of open routing protocols. Yes, open routing protocols are also part of it. Software developed defined network architecture decouples network forwarding and controlling functions. Remember, we separate it into different layers, right? Controlling layer, network forwarding. SDN refers to set of tools used for network planning. No, right? SDN refers to application level network topology technology. No, it's not application level, it's total solution. I think the answer must be C or B, but this is just part of it. Open routing protocols are there, but it's just part of it, right? Uh, what is the answer? If I can remember, it should be C. Yes, answer is C. What is the purpose of southbound API? Remember southbound API, northbound API. Let me open the note again. Software defined networks. So this is traditional approach. Traditional approach. Data control management. Data control management. So this is traditional. So then new approach. So this is your southbound API, more closer to the hardware. In between northbound and southbound, we have modules, right? Modules, right? In between northbound and southbound, we have the modules. So southbound, we have the open flows. Northbound, southbound, so we have the control layer. Below southbound, you have the hardware, right? So between northbound and southbound, you have the control layer, software-defined network controllers. It is the API that switches use to access other switches. Southbound API is used by controller to manipulate switches. Application use southbound API to control the controllers. Right? Control is there, right? So application use southbound API to control, right? But southbound API is below that, open flows. It's little bit fussy for me. Anyway, what is the answer given? It's little bit fussy, the answers are. Yeah, examiner has taken southbound API is used to controllers to manipulate switches. Yeah, program the network devices. Network devices are pretty much switches, right? Yes. Right. So you can use here network devices is basically switch. Right. This is a super easy question. Which of the following is an application layer protocol? DNS. Obviously. What is the record type used for IPv4 address? IPv4A, IPv6, AAAA. So the answer is B. Okay, B. Right. So now we have covered 3 years of papers, both MCQs and structured. Both MCQs and structured. So that officially conclude, but uh, I will give you a little bit of an idea about how to add uh, having codes to a code in the next class. So then only it is fully done. Enterprise application development, we need to do not full three MCQs we have finished, but some questions we need to cover here. It will take another 1 hour. So then we'll finish the project management paper also. So our weekend class, we can finish EAD, project management, and maybe 1 or 2 paper of UXD also. Then I need one more class next week, possibly Wednesday, and that will be your last class, Wednesday class. But I try to finish as much as possible. Oh, I will try to take another, yeah. I will try to take Saturday class, right? Tomorrow class, if possible. Uh, that I will let you know today itself, right? Whether I can take tomorrow morning session or evening session, so that we can finish it in this weekend itself, okay? Rather than going for Wednesday, okay? But that I will let you know before tomorrow morning, okay? But my target is try to finish this weekend, okay? Right. Let's finish. Let's stop at this point.